Alright, we're going to look at balancing chemical equations. If you like doing puzzle type things, this should be fun for you. Alright, the learning target is simply that I can balance chemical equations. Shocker. Right, so we're going to look at this recipe first. So, in a large bowl, cream together butter and sugar until it's smooth. Beat in eggs and vanilla, stir in the flour, baking powder, and salt. Cover and chill the dough for at least 1 hour, or overnight. Preheat the oven to 400 degrees Fahrenheit, or 200 degrees Celsius. Roll out the dough on a floured surface 1/4 inch to 1/2 inch thick. Cut into shapes with a cookie cutter. Place cookies an inch apart on an ungreased cookie sheet. Bake 6 to 8 minutes in a preheated oven. Cool completely. Hopefully you can recognize what's wrong with this recipe. If not, I'll tell you in just a second, but feel free to pause and think about it. What's wrong is, hey, we don't have any amounts. How much cream, or sorry, how much butter, how much sugar, how many eggs, how much vanilla. It'll make a big difference if those cookies come out tasting wonderful or tasting like crap. Alright, so there are just a couple rules for how we balance actual chemical equations. So it's just like in that recipe, we need to know how much of each thing we have to make a good chemical recipe, chemical equation, and make it work out to be a real thing that is good. Rule 1, you can only change the coefficients. So it's the numbers out front. So like if there's a number out front of here, that's the coefficient. When we don't write 1, just like in math, you just have x, it really means 1x. So there's one H2O molecule here. So there's a 2 here, and there's a 1 that's hidden next or below the 0. Not the 0, the O. So if you cannot change that 1 to a 2. If you do, it becomes hydrogen peroxide, which is going to kill you if you drink it, compared to water, which is great to drink. So never change the little numbers, the subscripts. Only change the numbers out front. You can put a 2 here, or a 3 here, or a 4 here, but you cannot change the little numbers. Rule number 2. Keep track of your atoms. So count all the atoms you have on both the left side and the right side of the reaction, the reactants and the products, after every change you make. All right, whoop. Then, so let's do an example one. So write down this equation, and we're going to make a table and count the atoms we have on both sides of the equation. You may want to pause and write this down before I explain it. It'll probably make more sense that way. Okay, hopefully you now have a table and written down what's on the screen. We have a CH4 molecule and an O2 molecule on the left side of our reaction called the reactants. And then this reaction arrow is saying go to the product side of CO2 and H2O. So we're going to count. This is our balancing tower of power. Put all the elements you have up above vertically in this tower. Then just draw a line across the top for every single equation you get. On the left side, we put how many of this element, carbon, are on the left. So there's just C with the little hidden 1 there, so we have 1 carbon. On the right side, there's also carbon with a hidden 1, so it gets a 1. Hydrogen, we have 4 H's on the left. It's the only thing that has H's, so it gets 4. On the right side, hydrogen, we just have 2. Nothing else has H's in it on the right side, on the product side, so it gets a 2. Then oxygens, there's just the 2 from O2 on the left, and there's 2 here plus the 1 over here. So we have to combine all the oxygens on the right side, get our total down the right. This will be done eventually when these all match up, but right now it's not balanced, they're not even. So then we need to start to balance it. So we'll start on the left side and find the first non-balanced atom. I usually go down from the top bottom, so carbon, but that's already balanced, so we're good. Hydrogen is not balanced. There's 4 on the left and 2 on the right. So we need to add a coefficient. We can't change the little numbers, so if we need 4 hydrogens on the right, we need to take the 2 over here and get 2 more. So there was a hidden 1 here. We're now make it a 2 instead, and say we have 2 of this molecule, because that 2 is going to multiply by the 2 hydrogens we have here to get us 4 hydrogens total. When we do that, we can change this 2 to a 4 for 4 hydrogens. But wait, this oxygen changed. Why did that happen? Because we have 2 oxygens. That oxygen's also in here. You can kind of pretend this is all in one big box. It's a box of stuff. If you have 2 boxes instead of 1 box, everything in that box is going to double. Now some kids get in trouble by accident by saying, oh, we took 2 times this, so we're going to double the oxygens and go from 3 to 6. But you don't want to do that, you need to recount them. So we go, there's 2 times 1 oxygen is 2, and then there's 2 more here. So we got 2 from each of those. We'll then get a total of 4 oxygens, 2 from the CO2 and 2 from our 2 H2Os. So once we do that, we got carbon is even, hydrogen is even, oxygen's not even, but we're closer. Now we just have to go look at oxygen in our next step. Okay, so to get 4 oxygens on the reactant side, we need to put a 2 next to this O2, because 2 times 2 gets us 4. So now we'll have 4 O's on the left, 4 O's on the right. They're all even. It usually helps to double check, recount your atoms one last time once you think they're even. That'll make sure you've got it right. Now, if these numbers could all be divided by something, we have to do that. But since it's a 1, we don't see, a 2, a 1, and a 2, it's as low as they can get. They can't be reduced anymore, so we're good. Our final equation would look like 1CH4 plus 2O2 goes to 1CO2 plus 2H2O. That's the final balanced equation. See? Not too bad. Let's try another one. Before we do that, there's a few helpful hints here. If you see a group of atoms that occurs in the exact same order before the reaction and after the reaction, treat them just like one thing. So like polyatomics. So here there's an OH group on the left and an OH group on the right, exact same order, same group. I'm going to put down, I have a calcium in my tower, I have OH in my tower, I have lithium in my tower, I have that OH group. I'm going to treat them as if they're one atom. It'll make your life easier. You can do it the other way, but it takes more steps then. Nope, those lines don't quite match up. You get the idea. Okay, hint number 2. If a molecule has only one type of atom, balance that thing last. So like in this equation, we've got, like before we had O2, it's just oxygen. There's no other elements in there. There's no carbon, there's no hydrogen, there's no lithium, there's no anything else. Do that element last. And in general, if you're not sure, oxygen is usually the safest one to do last. It tends to mix up stuff the most. And then we'll simplify all of those coefficients, like I mentioned before, to the lowest whole number ratio. All right, so you have the steps, you have an example one, and some hints. Now, here's 5 example ones. Well, 5 example ones. There we go. So pause the video, give this a shot, try and balance these 5 using that same, so write them in your notebook, write them in Notability, pause it, and make a balancing tower of power, write in your elements, in the first one, P and O, and try and balance it so that in the end they all match up. When you're done, you think you have them, pause, and I'll show you the answers. If you've got questions, come find me, or look up other learning opportunities online. Okay, unpausing now. Here are your answers. Hopefully you got them right. Oh, arrow showed up later, but there they are. So there are your 5 balanced chemical equations. If you got them right, then you're doing pretty good. Do a little more practice, make sure you got it down. I think you'll be in good shape. If not, come talk to me, we'll figure out what's going on and make sure you get squared away. Adios.